So today we will study about telescope, right? Basically, telescope is a optical instrument. It is a optical instrument which is used to magnify the distant objects. Magnify the distant objects, right? Or you can say the objects which are placed very far. The objects which are placed very far. Basically, it magnifies the astronomical bodies. It magnifies the astronomical bodies. For example, we have sun, we have star, we have moon, and etc. Right? It basically magnifies these astronomical bodies. If we talk about the basic working principle, it basically increases the visual angle. It increases visual angle, right? It will increase the visual angle. Basically, if we talk about construction, it consists of a metal tube plus it consists of a two convex lenses, right? We have two lenses. First is objectless lens and second is eyepiece, right? Basically, first is object lens. Basically, here the object lens is quite big. It has large focal length. It has large focal length and it has large aperture. Now, what is aperture? Basically, aperture is the diameter, or you can say the area from which the maximum light enters. The diameter, right? This is the object lens, right? If not eyepiece, basically it consists of a small focal length, and it has small aperture. It consists of a small aperture. You can see the diameter is quite small over here, right? So let's look at how this telescope is made. Consider that this is your eyepiece. I'm writing here E, right? And this is your object lens, because as I said, it is quite big. This is the object lens. This is a principal focus. This is a focus. This is focus. Okay, basically we have to set the focus point in a way that both lens have a point which is their both, like they will share their focal point. That they will share their focal point. We have to keep like this. We have to set both lenses in a certain way. This is known as normal adjustment. This is known as normal adjustment, right? Okay, now basically as I said, this is a focus point. Basically as a body is a astronomical body, will parallel lines will come. So consider that the image this is focus. So when the parallel beam of light comes, they always meet at focus. So from focus there will be straight line and it will move from the focus, and from here the optical center. So these are the infinity, and then from the lines are coming from infinity, they will form a picture at the image at the focus. I'm writing F. Okay, now what will happen to the second lens? Now it will also from the edges, this is focus, this is like this, and from the here. So as you can see, these are parallel lines. So parallel lines never meet, right? Parallel lines never meet. So they will appear to be convergent. They will meet over here. So they will meet at the infinity, right? They will meet at infinity. So this is the working of the telescope. Now you can see over here. Okay, yes. So the image which is formed by the object lens is basically real, inverted, and diminished, right? the image formed by object lens is real, inverted and diminished. As you can see over here, this image is real, inverted and diminished, like as compared to this astronomical body. If we talk about eyepiece, the image over here is highly magnified. The image is highly magnified, plus it is virtual, but it is inverted. Why it is inverted? Because the object is quite is symmetrical, so it's symmetrical, so it won't get affected that the image is inverted or it is erect, right? So this is the working of the both lenses. Now basically this point, let's name these points. This is known as A, and this is B, this is C. Okay, basically this point is known as M, this is CM. So now let's prove the formula for this. Okay, from here this is focus, right? From here to here, this is the focal length of the eye of the object. This is the focal length of eyepiece, and we know that what is the length of basically lenses. This from here, one lens to another lens, one lens to another lens is known as lens. So now we can prove from here that the length of a lens is equal to f naught plus fe. F naught is basically focal length of object lens, and the plus focal length of eyepiece, right? Now basically let's prove the formula for the magnification. We know that magnification is equal to beta upon alpha. So let's consider, here we have to see basically triangles. We have a triangle over here which is CAM. So you can see over here, this is the angle is made over here, right? So according to the relations, you can see that here we can use a ratio which is tan theta, which is perpendicular upon hypotenuse. It will be basically in angle ACM. So we have to find the alpha, right? So we know that the tan alpha is equal to perpendicular upon base, right? Here the perpendicular tan alpha, so here the perpendicular was CM and the base was basically F naught. As you can see over here, the CM is perpendicular, right, and CA is basically the base, and base is equal to F naught, right? So let's talk about another triangle which is beta here, angle beta. So here BM is hypotenuse, CM is perpendicular, and CB is basically base, and here base is equal to focal length of eyepiece. So here this is equation number 1. Basically this is now in angle BCM, so we have to find the beta. So tan beta is equal to perpendicular upon base. Tan beta is equal to, now here it is equal to CM upon FE. So now we will compare these both equations, and it will be like we will put these both equations in this formula. Now basically what will happen, this will become tan theta will become theta is equal to CM upon F naught. Why? Because when the value of tan alpha is very small, then the alpha is equal to basically then the tan is equal to the theta. That's why. So it will be like this, and here it will be like beta is equal to CM upon FE, right? Now let's compare these both equations. Like you have to put the value of these both equations in this equation. So M is basically equal to CM upon FE, and here CM upon F naught. It will be CM upon FE cross multiplication F naught upon CM. These both will cancel, and here the magnification will be F naught upon FE. Like the magnification is directly proportional to the focal length of objective lens. If you increase the focal length of objective lens, the magnification will also increase. But if you increase the focal length of the eyepiece, the magnification will decrease. So I hope this telescope is working and the construction is all clear to you. If you have any kind of queries, you can ask me in the comment section. We're very glad to answer you guys.